Alright guys, in our previous lesson we talked about how we couldn't take the square root of a negative number. Well, that's about to change. The set of real numbers does not include all the numbers needed in algebra. For example, x squared equals negative 1. We compensate for this by introducing this imaginary unit I, which is defined as I equals negative 1. I equals the square root of negative 1, and therefore I squared equals negative 1. Complex numbers are formed by adding real numbers and multiples of I. It's really unfortunate, the naming scheme of things. It says imaginary unit, but they're not truly imaginary. It's just because real numbers had their name first, and if they're not real, then they're imaginary. They are useful numbers. You see them a lot in engineering, but just want to say that out front, that we're not just making up numbers to make the math work. That's not how this works. So in order to actually apply this, let's start by rewriting some of these. So we know that we can't take the square root of negative 25 as is. But if we do what we did before and separate this as the square root of negative 1 and the square root of 25, then with this new rule of I, then I can do this. And this would be 5i as an answer. The square root of negative 1 is I, the square root of 25 is 5. So 5i would be my answer. On 2, 15 is not a perfect square, and a perfect square doesn't live inside of it. So this would be the negative 1 times 15. And when I split that up, I is the only thing that comes out. So I get I square root of 15 as an answer. On 3, we'll simplify this. We got negative 1 times 144 times 2. The square root of 144 is 12. The square root of negative 1 is I. And 2 is going to stay put. So this is going to be 12i square root of 2. All right. On 4, we have negative times the square root of negative 1 times 9 times 2. Square root of 9 is 3. Square root of I is negative 1. Or square root of negative 1 is I. And so that's going to be negative 3i square root of 2. The negative out front doesn't change anything. But this is what we got. Okay, now, product and quotient rule. You're going to want to work these types of problems using the above property first. Because the quotient and the product rules only work on real numbers. So here's what we're talking about. You look at this, and there might be two different ways you think about doing this. All right, so if we apply what we just did, this would be 2i times 3i, which would give me 6i squared, and I squared is negative 1, which would give me negative 6. This is the correct way to do this. Now, as I said, when you look at these two problems, you look at them and you may consider, oh, well, I can just multiply those two together and get negative 4 times negative 9. And that's going to give me square root of positive 36, which is 6. All right, see how they're different? All right, one's right, one's wrong. The first one is the correct way to do it. Okay, so let's keep that in mind as we work ahead. So on number 5, this is going to be I squared of 13 times I squared of 13. When I multiply those together, I get I squared times 13. Well, remember, I squared is negative 1, so my answer is going to be negative 13. All right. On 6, I got I squared of 3. I squared of 8. This is going to be I squared square root of 24. I squared square root of 4 times 6. So it's going to be negative 2 square root of 6. And it's negative because the I squared is negative. The I squared is negative 1. So this is my answer. Okay. As we stated, this is going to be I squared of 30. I squared of 10. The i's cancel out. And so this is going to be 30 over 10. And then that's simply going to be square root of 3. All right, here we have I square root of 24. We have 8, square root of 8 rather. So I can actually pull this I out and do 24 over 8 at this point. And so that would be I square root of 3. All right, on number 9, I got I squared of 6 times I squared of 2 over square root of 3. Okay, on top that's going to be I squared square root of 12 square root of 3. All right, and now that's going to be I squared 12 over 3. So it's going to be I squared square root of 4. All right, square root of 4 is 2. I squared is negative, so that's going to be negative 2 is my final answer here. All right. Now, in a previous lesson, we talked about rationalizing denominators and multiplying by conjugates. Well, all right, so let's simplify these on number 10 and 11. And we're going to write it in the form a plus bi, which means we're going to write the real part first and then the complex part. Okay, so that's going to be negative 6 minus, let's see, it's going to be negative 1 times 4 times 6 all over 2. It's going to be negative 6. That's going to be minus 2i squared of 6 over 2. And because 6, 2, and 2 are all even, I can clean that up a little bit. So it's going to be negative 3 minus I squared of 6. And I got the real part in front of the complex part, so it's all good. That's my answer. On negative 3, or sorry, on 11, I got negative 3 plus square root negative 1 times 9 times 2 all over 24. All right, so I got negative 3 plus, it's going to be 3i square root of 2, and 3 goes into 24, so this is going to be negative 1 plus I square root of 2 over 8. So you can leave it like this, or you can split the fraction. And if you split the fraction, it looks like this. Let me do it this way, or negative 1 over 8 plus I squared of 2 over 8. So you can do either way. It really depends on how picky a person is, but both answers are correct. All right, adding and subtracting. Okay, so when the parentheses are separated by a plus sign, I just drop the parentheses and get to work. And it's just like, you're just combining like terms. So 3 plus 9 is 12. 2i minus 3i is minus I. And again, my real is in front of my complex part, so that's my answer, 12 minus I. When the negative is in front of the parentheses, you distribute that negative through that parentheses behind it. So 2 minus 5i comes down, minus 3, minus 4i. All right, distribute the negative. 2 negatives make a positive, so it's plus 2 minus I. All right, and then I combine like terms. Let's see, I got 2 minus 3 plus 2. So 4 minus 3 is 1. Negative 5, negative 4, negative I. That's going to be minus 10i. So 1 minus 10i is my answer. All right, on number 14, I got negative I squared of 2 minus 2 minus 6 plus 4i squared of 2 minus 5 plus I squared of 2. All right, so I got negative 2, negative 6, and negative 5. So it's going to be negative 13. And then I got negative I, positive 4, positive 1. So these two terms are going to fall out. And I'm simply left with 4i. So plus 4i squared of 2. Negative 13 plus 4i squared of 2 is my answer. All right, products. So we distribute the first term, come back and get the second term, distribute it, and combine like terms. So I got 2 times 3 is 6. 2 times negative 2i is 4i. I times 3 is 3i. And then I times negative 2i is negative 2i squared. Okay, well, a couple things. Let's combine our like terms. So it's going to be 6 minus I, and then minus 2 times negative 1, because I squared is negative 1. Okay, so that's plus 2. So 6 plus 2 is 8. So you got 8 minus I. 8 minus I is your answer. All right, anytime you see a binomial squared like this, go ahead and write it twice, and then do what you just did. 3 minus 2i. All right, so 3 times 3 is 9. 3 times 2i is negative 6i. Negative 6i, and then plus 4i squared. All right, so you got 9. That's going to be minus 12i plus 4 times negative 1. So 9 minus 4 is 5, so 5 minus 12i is your answer. All right. So notice the difference. So 16, you had two binomials. They were the exact same, and they had the same sign. On 17, you have the same binomial, except one has a minus, one has a negative. Or one has a plus, one has a minus. So look what happens here. So if I do negative 2 times negative 2, I get positive 4. Negative 2 times positive 3i is going to be minus 6i. Negative 3i times negative 2 is plus 6i. And then negative 3i plus, or times 3i is minus 9i squared. Well, because the signs were different, that middle term falls out. And so you got 4 minus 9 times negative 1. So that's 4 plus 9, which is 13. So these are a special relationship. They're called complex conjugates, and they always produce a real number. So now that you know that the middle term is going to fall out, what you could do is square the first term, square the last term, and then add them up. So there you go. All right. In a previous section, we talked about rationalizing denominators. We're going to do something similar here, but we're going to multiply by the complex conjugate in order to get rid of the i's out of the bottom. And so just like with rationalizing denominators, we wanted to get the square roots, or we wanted to get the radicals out of the bottom of the fraction. We want to do the same thing with i's. We don't want the i's in the bottom of the fraction. And so we're going to multiply by the complex conjugate. So on 18, we have 1 plus 2 in the bottom. So that means I'm going to multiply by 1 minus 2i on top and bottom. Because whatever you do to the bottom, you do to the top. That's what makes it legal. And so on top, I got 6 plus 2i times 1 minus 2i. And then on the bottom, I'm going to square my first term. So 1 times 1 is 1. And then 2i times 2i is 4i, and it's going to be minus 4i squared. All right, so let's clean up the top. So 6 times 1 is 6. That's going to be minus 12i plus 2i minus 4i squared all over I squared is negative 1, so 1 plus 4 is going to be 5. So we got 6. Let's do this. We got 1 minus 4, negative 1. All right, so it's going to be minus 10i and minus 4 times negative 1 all over 5. All right, so 6 plus 4 is 10, so you got 10 minus 10i over 5. 5 goes into 10, so this is going to be 2 minus 2i to wrap things up. Okay? All right, same thing on 19. This time I'm going to multiply by 1 minus i, top and bottom. All right, so on top, 1 times 1 is 1. 1 times I is negative I. That's going to be negative 3i, and that's going to be positive 3i squared over 1 minus I squared. Okay, so it's going to be 1 minus 4i plus 3 times negative 1 over 1 minus negative 1. All right, so 1 minus 3 is going to be negative 2 minus 4i over 2. And once again, 2 goes into both of those, so it's going to be negative 1 minus 2i. Negative 1 minus 2i is your answer. All right, 20. I still want the i's out of the bottom. I don't really care about the negative though. So I'm going to multiply by just I. And so that's going to give me 8i on top and negative I squared on the bottom. Okay, so this is going to give me 8i over negative times negative 1, which is just 8i. The two negatives make it cancel and make that a positive 1, and anything over that is just going to be 1. So 8i is my answer. All right, now, probably one of the more important things to talk about in this section is the powers of I. So as you can see, I is the square root of negative 1. And so we can simplify that and just say I to the first is I. All right, if I is the square root of negative 1, then I squared is negative 1. So I cubed is the first two times each other. So I times negative 1 gives you negative I. And then I to the fourth is I squared twice. So negative 1 times negative 1 is positive 1. This pattern repeats itself over and over again. So what you end up with is, so like on 21, if it is divisible by 4, all is well. So let's take a look at this. 25 divided by 4 gives you 6 1/4. So I don't really care about the 6. What I care about is, first of all, this is going to give me I to the 24th times I to the 1st. I know this one is going to go to 1. Okay, so this ends up being 1 times I, which is just I. So what I really care about is this piece right here. What is that numerator of that fraction? And that tells me which of these am I going to choose for my answer. You only have 1 of 4 choices, all right? So that makes it really simple. 32 divided by 4 is 8 with no fraction left over. So this is just 1. 23, this one's tricky, all right? You have I to the negative 14, but I want it to be a positive exponent. So I to the negative 14 times I to the 16 would get me into the positive territory. And I'm multiplying by 1. So 16 is divided 4 goes into 16 evenly. So I'm multiplying by a multiple of 1. Okay, so that's why it's not 15 or 14 or anything like that. I'm multiplying by I to the 16th because that's the nearest multiple of 1 that gets it into the positive exponents. And again, this is true because when I multiply like bases, I add the exponents. So this ends up being I squared, which we know is negative 1. All right, 24. All right, this one goes back to that negative exponent rule that we talked about in a previous lesson. So what I'm going to do here is to make this a positive 11, I'm just going to bring it up. And now I go into, all right, 11 over 4 is 2 3/4. Okay, so that's going to be I to the 8th. 4 times 2 is 8, and then I cubed. So I to the 8th goes to 1, and then I cubed is negative I. So my answer is going to be negative I. And that's that. Again, you're pulling from those 4 different options, and is it divisible by 4? If it is, great, it goes to 1. If it's not, look at your remainder. Do I have 1 left? Do I have 2 left? Do I have 3 left? And if so, you pick your answer from that list. All right, guys, that's the end of this lesson. I'll see you in the next one.